you will study preparation of colloids and purification of colloids. Here, preparation of colloids by chemical methods, by electrical disintegration or Bradig's arc method, and peptidation, and purification by dialysis, electrodialysis, and ultrafiltration method. Preparation of colloids by chemical method. Colloidal, colloidal dispersions can be prepared by chemical reactions leading to formation of molecules by double decomposition, oxidation, reduction, or hydrolysis. As arsenic oxide double decomposition reaction by H2S gives arsenic sulfide sol plus water. Sulfur dioxide plus H2S gas by oxidation gives sulfur plus water. AuCl3 and formaldehyde reduction in water gives gold salt, formic acid, and HCl. Ferric chloride water by hydrolysis gives ferric hydroxide salt plus HCl. The second method is Bradig's arc method. This process involves dispersion as well as condensation. Colloidal salts of metals such as gold, silver, platinum, etc. can be prepared by this method. In this method, electric arc is struck between electrodes of the metal immersed in the dispersion medium. The intense heat produced vaporizes the metal, which then condenses to form particles of colloidal size. Here, the figure given alongside Bradig's arc method, the electrodes are made up of metals which is used to make the salt. Now peptidation. Peptidation may be defined as the process of converting precipitate into colloidal salt by shaking it with dispersal medium in the presence of small amount of electrolyte. The electrolyte used for this purpose is called peptidizing agent. This method is applied generally to convert a freshly prepared precipitate into a colloidal salt. During peptidation, the precipitate adsorbs one of the ions of the electrolyte on its surface. This causes the development of positive or negative charge on peptidation on precipitates, which ultimately break up into smaller particles of the size of a colloid. You will learn about the phenomena of development of charge on solid particles and their dispersion in the next section under the heading Charge on Colloidal Particles of Properties of Colloids. Now, purification. Colloidal solutions when prepared generally contain excessive amount of electrolytes and some other soluble impurities. While the presence of traces amount of electrolyte is essential for the stability of the colloidal solution, large quantities coagulate it. It is therefore necessary to reduce the concentration of these soluble impurities to a requisite minimum. The process used for reducing the amount of impurities to requisite minimum is known as purification of colloidal solution. This is done by electrolysis, study the part, electrodialysis, first one dialysis, second one electrodialysis, and third one ultrafiltration method. You will study from the notes. Now, properties of colloidal solution. Here, various properties exhibited by colloidal solutions are described below. Number one, they follow colligative properties. Colloidal particles being bigger aggregates, the number of particles in a colloidal solution is comparatively small as compared to true solution. Hence, the value of colligative properties, that is osmotic pressure, lowering of vapor pressure, depression in freezing point, and elevation in boiling point, are of small order as compared to values shown by true solution at same concentration. Next, it shows Tyndall effect. As you know, Tyndall effect is observed only when the following two conditions are satisfied. The diameter of the dispersed particles is not much smaller than the wavelength of the light used. And second, the diffractive indices of the dispersed phase and dispersal medium differ greatly in magnitude. Now, color. The color of colloidal solution depends on the wavelength of light scattered by the dispersed particles. The wavelength of light further depends on the size of matter of the particles. The color of colloidal solution is also changes with the manner in which the observer receives the light. For example, a mixture of milk and water appears blue when viewed by the reflected light and red when viewed by the transmitted light. Finest gold salt is red in color. As the size of particles increases, it appears purple, then blue, and finally golden. The colloidal particles also shows Brownian movement. Now, charge on colloidal particles. Next video, I will discuss about the topic. Thank you.